Okay, so quick review here, guys. Scalar quantity. Okay, scalar quantity has what? Oh, how quickly we forget. Nope, no direction, just a... Okay, distance is an example. Okay, magnitude only. Alright, so distance is an example of a scalar quantity, because if I gave a distance, that would be 65 kilometers. Alright, I don't say which way the 65 kilometers is, just 65 kilometers. Okay, or I could say mass. Okay, mass is another one, 75 kilograms. Mass doesn't have a direction. Okay, time. Okay, 4 days. Again, I don't write a direction on that. They're scalar quantities. True. No, the one with the arrow above it would be a vector quantity. The arrow denotes that there is a direction. All right, so vector quantities. Okay, they have magnitude and direction. Okay, so the scalar quantities we dealt with: distance, speed, okay, which is v without the arrow over top, and time, which is t. Okay, those are the ones we dealt with. Now, vector quantities, okay, the ones we dealt with: displacement. And if you recall, displacement is how far and in what direction in a straight line you have come from your starting position. Remember, it is always reference to the starting position. Okay, velocity, how fast and in what direction you are going. Okay, and then and that's it. Those are the vector quantities we've dealt with thus far. All right, the formula we've dealt with so far: v equals d over t, or v equals d over t. All right, is this ringing a bell a little bit? Now, on occasion, we might run into questions that have, let's say, are describing a trip, but this trip has two parts. All right, then, okay, we modify these formulas to be average. Whoa, that's a terrible v. Okay, v average, okay, equals the total displacement, or so, sorry, total distance in this case, over total time. Right? Or if we were dealing with this one, it's the same thing. The average velocity is the total displacement over the total time. Okay, everybody with me on that? Okay, we ran into a few, and we'll do a few here as examples just to refresh our memory. All right, but those are the things we dealt with kind of Tuesday, Wednesday, Thursday there before the Easter break. All right, so let's look at an example here. So we'll look at an easy example. All right, so when we read this question here, it says, a deer runs 100 meters in 20 seconds. How fast is it going? All right, this 100 meters, what were we given with that 100 meters? That's distance. How do I know it's distance and not displacement? Doesn't say what direction, right? Okay, it just gives me a magnitude, so I know that that's just distance, 100 meters. Okay, obviously the 20 seconds is time, right? And it's asking how fast is it going? So does it want to know speed or velocity? Speed. Doesn't say how fast and in what direction it's going, just how fast. All right, so we're looking for v. V equals d over t. Okay, so 100 over 20 equals 5.0 meters per second. All right, that's as easy as they get. Okay, we did a few like that the week before Easter. Okay, making sense there, guys? Caroline? if you run into a question where, let's say I gave it as 0.1 kilometers in 20 seconds, yeah, you'd probably want to change it so that it was meters. Okay. Basically, if you have units that don't match, then you have to make them so that they do. All right, in general. Well, you can just leave it as meters per second, right? But if you were given kilometers per hour and seconds, then you might want to change the seconds to hours, right? That way your time units match. Okay, your units always have to match. All right, tougher example. Not that much tougher, but a little bit tougher. Okay, so on this one here, we're talking about this jet that's traveling at 330 meters per second, which incidentally is the speed of sound, okay, to travel 400 kilometers. What was I given in this question? Right, I was given speed because it doesn't tell me what direction. It just says 330 meters per second, and I was given distance. Okay, 400 kilometers. Now this is the thing Caroline was mentioning just a minute ago. My speed is in meters per second, but my distance is in kilometers. Do my units match? Okay, so I got to convert kilometers to meters. Right? Well, 400 kilometers is 400,000 meters because there's 1,000 meters in a kilometer. Okay, everyone with me there? Now, it's asking me how long is that going to take? Okay, so what am I asked to find here? Time, right? Anytime it's asking how long, we're looking for time. All right, so time equals, well, we got to figure that out. V equals d over t. I need time by itself and on the top of the equation. So I'll multiply both sides by t and then divide both sides by v, and I'm left with t equals d over v. So I plug in my numbers. 400,000 over 330 meters per second. All right, so we're looking at 1,212.12 seconds. Okay, now, is that a meaningful number? Not many of us know how long that is. Okay, it's a little less than a half an hour. Okay, but can we leave it as that? Yeah, we can. Okay, we had seconds, so we can leave it as that. So we'll just say 1,212 seconds. Okay, everybody right with that one? All right. Now, let's see if it changes at all if I bring direction into this. Okay, so this bird flies 650 meters north at a velocity of 9.0 meters per second north. How long is it flying? Okay, does this really change a whole lot what I do? Not for this question, no. Okay, for this question, it's still pretty much what we were doing before. Yes, I was given a velocity instead of a speed this time. All right, 9.0 meters per second north. Okay. Displacement, 650 meters north. Right? How long does that take? Well, The formula is still V equals d over t. It still manipulates out pretty much the same way. All right, so when it's a one-step problem like this, scalar versus vector, not really a whole lot different. The only time you're going to start to see a difference is on questions with more than one part. Okay, so if we're looking at this here and we want to get t by itself, t equals d over v. All right, so we got our 650 over 9. Okay, so it would be flying for 72 seconds. Okay, everybody all right with that one? All right, now this last example I'm going to do, I want you to write down, get the whole thing down, because it's going to be like some that you're going to do. What are we on here? Example 4, right? Okay. Okay. So on a question like this, okay, there would be like maybe an A and a B. The first part would be what's the average speed, and the second part would be what's the average velocity. Okay? And we would solve those similarly, but there's one important difference, okay, that would come into play. If I want to find average speed, speed is total distance over total time. Okay. How far does this elevator go? Yeah, how far does it go in total over the whole trip? Yeah. 145 meters. Okay? Remember, distance and speed are scalar. They don't care whether the elevator has gone up or down, just how far the elevator has gone in total. Right? This is where that scalar vector thing becomes different. Right? In this case, I take my two even though they're displacements, I treat them like distances. I ignore the direction that was traveled, and I simply add the magnitudes together. The total distance traveled is 145 meters. Okay? The total time is 50 seconds. Okay, so when we do that, 145 divided by 50 gives us 2.9 meters per second. Okay. Now, probably if I gave you one like that, I wouldn't give you the distance and the time for both parts. I would probably make you find the time or find the distance for one of them. Okay, I'd probably give you their speed or their velocity in each part. Okay, so for part B would be what's the average velocity? Okay, so average velocity is total displacement over total time. Is the total time any different in this one? No, the total time is still 50 seconds. Time is scalar. Okay, you always add time. You never subtract time. All right, so we know that whatever the displacement is, it's going to be over 50 seconds. So the elevator goes up 85 and then down 60. What's its displacement? Somebody whispered it. 25 meters up. All right, it went up 85. Okay, so if we were in the elevator, here's the ground. We went up 85 meters and then came down 60. So the difference there is 25 meters up. We're still 25 meters above the ground where we started. All right, everyone follow me there? Okay, so this is where direction is important. Okay, so my overall displacement is 25 meters up. Okay, so now I can divide those numbers. 25 over 50. Why did I do that? Okay, is 0.5. 0.5 meters per second up. Okay, is this ringing a bell? All right. Now, I don't think anyone's done both sides of that sheet. If I'm wrong, congratulations, you can wait and just chill out for a little while. Okay. If you are not, which I'm assuming is probably most of us, okay, I want to finish up that sheet I gave you before Easter. Okay, I'll go over a few more examples, okay, in about 20 minutes or so, and I'd be happy to go over any questions from the sheet that you don't understand. All right, but that's what we want to finish up, is that worksheet. Okay, especially the vector side. I think most people are done the first side where it was all scalar, but I want to get going on the vector side, which is the back side of that sheet. True. Oh, fourth drawer unit there. Okay, if you weren't here and didn't get one of these, fourth drawer of the drawer unit, okay, you can grab them from there. Yep. Yep. Okay, so for this submarine question, number 9 on the second side, okay, we got this submarine on the ocean surface. It dives underwater. In the process, it descends 400 meters and then rises 350 and then descends 1,000. So, okay, first it goes down 400. Okay, then it comes back up 350. Right, so now it's how far below the surface? 50. Now it's going to descend 1,000. So how far below the surface does it end up? 1,050. That's its displacement. Okay, its displacement is 1,050 meters down. Okay, this maneuver takes 4 minutes. Okay, what's the velocity of the sub? Well, let's change the minutes into seconds, just for argument's sake. Okay, so 4 times 60 is 240 seconds. Everybody with me there? All right, so now all I have to do is go V equals 1,050 meters down, okay, over 240 seconds, and that should give me my 4.375 meters per second down. Okay, if you didn't convert the minutes to seconds, then you'd go 1,050 over 4, and you get meters per minute down. It'd be a slightly different number. Okay, is that good? All right, any other ones there, guys? Alex? Number 6 on the second side? Okay, so this one here, it's got trig in it. That's why it's got the 3 stars beside it. Okay, you're not going to run into one like this in Science 10. I just put it on there to see if somebody was really paying attention. All right, so this one here, it's going 25 meters per second due south off the coast of Cuba, okay, for 6,800 seconds. To avoid the Bermuda Triangle, the ship turns and travels 130 kilometers due east for 5,400 seconds. So what I need to do is find out how far it goes in each part. Okay, so the first displacement, I'm going to take the 25 meters per second and multiply by 6,800. Whoop, has to be on. Okay, sorry, 25 times 6,800, okay, gives us 170,000 meters. South, and then the second displacement, okay, same idea here, is actually, sorry, we don't even need it, is 130 kilometers due east. That's 130,000 meters east. So I go south and then I go east, all right, which means my overall displacement is this line here. Everybody follow me? Okay, remember, displacement is how far and in what direction you are from where you started. So how do I find the hypotenuse of this triangle, knowing that this side is 170 kilometers and this side is 130 kilometers? Right, it's Pythagorean Theorem, the Greek geek. Okay, Pythagoras is the Greek geek, by the way. Okay, in my class. So 170 squared plus 130 squared gives us 214 kilometers. Okay, and then what we have to do after that is figure out the overall displacement. So 214 kilometers divided by the total time, and that'll give us our velocity southeast. Okay, if you were truly doing this, you would also have to find this angle. Instead of southeast, you would have to give me an angle east of south or south of east. Okay, and that would involve having to use trigonometry, which in this case would be tan to the minus 1 of 130 over 170, right? Opposite over adjacent, SOHCAHTOA. Okay, but you don't have to do that in Science 10. Okay, you won't ever get one like that on a test or a quiz. Okay, any others? So, number 3, second side. All right, so we got this jetliner traveling at 350 kilometers per hour due east for 45 minutes. Okay, so here's what, guys, pay attention here. Okay, so for part 1 of this, we know that that shouldn't say speed, that should say velocity because they did give me a direction. Okay, 350 kilometers per hour, okay, east. And the time there is 45 minutes, but this is in hours. Can I easily convert minutes to hours? 45 minutes is 0.75 or 3/4 of an hour. All right, for part 2 of this trip, okay, it travels west at 375 kilometers per hour. Okay, sorry, that's west for 30 minutes, which is 0.5 hours. All right, so now all my units match, right? I've got kilometers and hours. Okay, how far did the plane go? Well, I got to find the displacement here for each part. Okay, so for the first part, that's going to be 350 okay, times 0.75 gives us 262.5 kilometers east. Okay, same thing over here. 375 times 0.5 should give us 162.5. That doesn't seem quite right. How about I stop guessing? 187.5. Okay, 187.5 kilometers west. All right, so for part A, it says, how far does it go? If I'm trying to find how far does it go, am I concerned with the west and east? No. So I just add these together, okay? 262.5 plus 187.5 will give me 450 kilometers. That's how far it traveled, the distance traveled. Okay, what's the plane's displacement? Well, okay, take this. It's east, subtract the west, because it's backtracking now, and we'll get 75 kilometers east. It obviously went further east here than it went west. Okay, everyone with me on that one? And then the last part, what's the average speed for the entire trip? Well, average speed is total distance, which is 450, over total time, which is going to be an hour and a quarter. Okay, and that should give us 360 kilometers per hour. All right. Does that make sense, Sophie? Okay, any other ones? All right, I want to go back to the elephant question I made up there. Okay, so we got this herd of elephants. And in a trip consisting of 3 parts, they end up traveling north. We don't know how far. Okay, in part 1 of the trip, okay, the elephants walk for 1.1 hours. Okay, at a velocity of 3 meters per second north. Okay, and then in part 2, okay, they walk 7 kilometers south in 1.5 hours. Okay, and then lastly, they walk 4.5 meters per second north, okay, for another 2 hours. Okay, What's the overall distance traveled? Well, I only got d in one of these things. Okay? Can I find d for these other parts? Yeah, but what do I have to do with the time? Does my time unit match my velocity unit? All right, so I got to turn the hours into seconds. So I multiply by the number of seconds in an hour, which is 3,600. 60 times 60, right? There's 60 seconds in a minute times 60 minutes in an hour, 3,600. All right, so my time in actuality here, okay, is going to be much bigger than that number. So I'll have 3 meters per second times 3,600 times 1.1, right? So 3,960. Okay, we multiply that by the speed, or sorry, the velocity, 3. All right, so these elephants travel 11,880 meters in this first part. And that is north. All right, in the second part, they already tell us the distance. It's 7,000 meters south. Okay, don't need to do anything there. But we do have to calculate distance here, or sorry, displacement here in part 3. All right, so same idea. 3,600 times 2 is 7,200, okay, seconds. So d equals 4.5 times 7,200. All right, so in that part they travel 32.4 kilometers. Okay, can I find out how far they go, overall distance? Okay, if I'm finding distance, does whether they went north or south matter? Okay, doesn't. So I take my 11,880 meters plus 7,000 meters plus 32,400 meters, and I will have the total distance traveled. All right, so these elephants walked 51,280 meters, so 51 kilometers. Okay. Everyone with me there? All right, so that's the easy part of that question. What's the average velocity of the elephants? If I want to find average velocity, what two things do I need? Average velocity is, right, total displacement over total time. Okay, well, I've got the times. Okay, they're not. Okay, so I can go 1.1 hours, 1.5 hours, and 2 hours. Okay, I can do that. That's no problem. Okay, so 2.6, sorry, 4.6 hours is our total time. Okay, is it okay that I have that in hours? I can have meters per hour for my units for velocity, or I can have kilometers per hour. It doesn't really matter. Okay, now. I also need now the total displacement. Does direction matter for total displacement? Yes. Okay. So I have to add the norths and subtract the souths. All right. So I'll have 11,880, okay, plus the 32,400, because those are both north, minus the south, 7,000. All right. So my total displacement is 37.280 kilometers. Okay, divide that by the time, 4.6 hours. They walk at 8.1 kilometers per hour. North, because it's a velocity, right? So my final answer there would be 8.1 kilometers per hour north. Okay, so yes, a question like that has got a lot of steps. But is it pretty much the same steps all the time? It's always some manipulation of v equals d over t. All right, so if you ever run into a question that's got many parts, find all 3 for each part. Okay, then you'll have everything you could ever need. All right. Okay, you got about another 20 minutes or so. Okay, let's finish up that sheet. So tomorrow we can get started on graphing. You will not have a quiz tomorrow, but you will have one on Wednesday, because I'm not here tomorrow. Okay, I'm at a zone meeting. Okay, so you will not have a quiz tomorrow, but you will be doing a bunch of stuff on graphing. If you do not want to have to use my ghetto graph paper, bring your own. Okay, I'm only going to give you graph paper one day. Okay, I'm not going to continue to give it out because, well, I don't want to. I don't want to have to keep going to the photocopier. Okay, you're not going to need much graph paper in this course because if we do graphs, I'd prefer you do them on Excel and pop them into your Google Docs when you submit them to me anyway. Okay, but for the first little bit, just getting the mechanics of graphing, we'll do them by hand. Okay, so if you don't like my graph paper, bring your own. It doesn't hurt my feelings at all. Okay, all right, back to work on that sheet there.